Rutherford was interested in knowing how the electrons are arranged within an atom. Rutherford designed an experiment for this. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil like this, like this, like this, like this. He selected a gold foil because he wanted as thin a layer as possible. This gold foil was about 1000 atoms thick. Alpha particles are doubly charged helium ions. Since they have a mass of 4u, the fast-moving alpha particles have a considerable amount of energy. It was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. Particle scattering experiment gave totally unexpected results. Most of the fast-moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. On the basis of his experiment, Rutherford put forward the nuclear model of an atom, which had the following features. First one, there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The second one, the electrons revolve around the nucleus is well-defined orbits. The third one, the size of the nucleus is very small as compared to the size of the atom. Drawbacks of Rutherford's model of the atom. The orbital revolution of the electron is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, charged particles would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. If this were so, the atom should be highly unstable and hence matter would not exist in the form that we know. We know that the atoms are quite stable.